This is Pre-Calc 12, Chapter 5.6. We're going to be analyzing logarithmic functions. Basically, we're looking at transforms. So if you understand transforms from the previous chapters, then this will be easy. You need to recall the change of base. Log base b of x equals log base a of x divided by log base a of b, where a and b and x are all positive, and a and b does not equal 1. Okay, to change log 88 to log base 2, and we use LG in computing science because log base 2 is commonly used in computing. Okay, so we have log base 2 of 88 equals log 88 divided by log 2. Okay, transformations uses the same letters as exponentials. We have y minus k equals c log base a of d times, in brackets, x minus h, where a is positive, c and d cannot equal 0. And we're transforming the base function, which is y equals log base a of x. And again, C is vertical scale and flip, D is horizontal scale and flip, H is horizontal shift, and K is vertical shift. And if we're transforming XY, this goes to X over D plus H and CY plus K. And what is the easiest point to transform? Well, log base A of 1 equals 0. So that point is 1, 0. And to get easy points, you can use the exponential function. Rather than the log function. It's just easier to generate points. So here's an example. Draw the image of y equals log base 2 of x with a transform of y equals 3 log base 2 of 2 times x minus 1 in brackets minus 4. So we have c is equal to 3. This means vertical stretch. We have d is equal to 2. This is a horizontal compression of a half. We have h equal to 1. This is right. And we have k equal to negative 4. This is down. Okay, and it's easy to get points. We have 2 to the power of 0 equals 1, 2 to the power of 1 equals 2, 2 to the power of 2 equals 4, 2 to the power of 3 equals 8. That covers 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3. And 2 to the negative 1 is simply 1 over 2. 2 to the negative 2 is 1 over 4. And 2 to the negative 3 equals 1 over 8. Okay, so because it's the inverse function, this is now our x, and the exponent is our y. So we can go ahead and use our formula. This is 1 over 2 plus 1, and 3 times 0 minus 4. This simplifies to 3 over 2 and negative 4. So 3 over 2, 1, 2, 3, 4. Next point, substitute in 2 over 2 plus 1. 3 times 1 minus 4. This simplifies to 2 and negative 1. 2 and negative 1. Next point, 4 over 2 plus 1. 3 times 2 minus 4. This simplifies to 3, and 6 minus 4 is 2. So 3, 1, 2, 3, 1, 2. And next point, 8 over 2 plus 1. 3 times 3 minus 4. This gives us 5. And 9 minus 4 is 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And we smoothly join our curve. And it helps to show which points are corresponding. This one comes down to here, this one comes there, this one goes over there, and this one goes up there. And if we flip to the next page, we want more precise definitions. The definition of an image is simply the result of the transformation, and more precisely, it's a subset of the transform that we actually graph. So let's pop back up here. This is the image. Okay, so if we just take this piece as our pre-image, this is our image. This is a subset of the whole curve if we extended it this way and extended it that way. And flipping back over to the other page, the pre-image is a subset of the domain that is used to generate an image. So the pre-image is this purple line, and it's a subset of the whole red line. Okay, let's go back to the next page. And just to be clear, subset just means part of the whole. The transformation image of the graph of y equals f of x is represented by the equation y plus 3 equals negative 2 log base 2 of negative 4 times x plus 2 in brackets. The point negative 4, negative 9 lies on the image of the graph. What is the corresponding point on the graph of y equals f of x? I've highlighted this in red. This is what you need to notice when you're looking at a test or homework questions. This point lies on the image graph. This means we're working backwards. But we still need to pull off the coefficients. C equals negative 2, D equals negative 4, H equals negative 2. Remember, we changed the sign. K equals, and we changed the sign here as well, negative 3. If this was on this side, we wouldn't need to change the sign. So the formula we start off with is x pre-image divided by D plus H equals x image. And we do 2 steps of algebra and we get x pre-image equals D times x image minus H in brackets. And for the y values, we have C times y pre-image plus K equals y image. And again, 2 steps will give us y pre-image equals y image minus K divided by C. And if you're not sure what the 2 steps are, you can look back at your old notes from previous chapters. So we have x pre-image equals D, that's negative 4, x image, that's negative 4, minus H, that's minus negative 2, substitute with brackets. So we have negative 4, this is minus negative 2, that's plus 2. So negative 4 plus 2 is negative 2. Negative 4 times negative 2 is positive 8. Y pre-image equals y image, that's negative 9, minus K, minus negative 3, all divided by negative 2. Minus negative 3 is plus 3. So minus 9 plus 3 is negative 6 divided by negative 2. And that gives us positive 3. The preimage of negative 4, negative 9 is 8, 3. Remember to write this as a coordinate. It needs brackets around it, round brackets. Next problem. Determine the logarithmic transformation of the function given the preimage f and the image g using only scaling and flipping. So we're given a point and a corresponding point. Use only the variables that are given, otherwise there will be a linear system of more than 2 variables. Okay, so this is telling us only scaling and flipping. That must mean we're dealing just with C and D, and H and K are just 0 for this problem. So we don't need to put H and K in there. A equals XA, YA. A prime equals X prime A, Y prime A. So X prime A equals XA over D. Now we just substitute. Negative 5 equals negative 2.5 divided by D. D is in the denominator, so we move it into the numerator on the other side. Negative 5 is on this side, so we cross multiply and put it in the denominator on the other side. Negative 2.5 divided by negative 5, and we have D is equal to 1/2. Y prime A equals C times YA. So negative 1 equals C times 1. So C equals negative 1. Recall that our answer must be in the form g of x equals C times f of dx. So our answer is g of x equals negative, the negative here, f of 1/2 x. Okay, some of you are going to calculate d here, and you're going to want to reciprocate. It's just dx, so don't take the reciprocal of this and put 2x. For this technique, does it matter what kind of function that we are transforming? And the answer should be no, because we are using the same formula over and over again. This is the same formula that we've been doing all along. And one last problem. Determine the logarithmic transformation of the function given the preimage f and the image g. We have A prime, B prime. All the primes are going to be for the image, and the ones that don't have the prime are the preimage. So we just use our formula. X prime equals x over d plus h. And we substitute. We're going to do this one in red. We're going to do this one in blue. Okay, so we have 6 equals 4 over d plus h. Over here, we have 8 equals 8 over d plus h. A and A prime. B and B prime. Doesn't matter which one we solve first. There's no zeros here, so it doesn't make it any easier. So we move this to the other side. We have h equals 8 minus 8 over d. Now we substitute over here, and we substitute down here. We have 6 equals 4 over d plus, use brackets, 8 minus 8 over d. And we go ahead and solve. This 8 comes over to the other side. We have minus 2, 6 minus 8. We have 4d minus 8d, so that's negative 4 over d. And we move d over to this side. In the numerator, we take the negative 2, move it in the denominator on the other side. And that's cross multiplying, so d equals negative 4 over negative 2, and that equals positive 2. Now we jump over here. We take this one, move it down here. So we're substituting d equals 2 into this formula. H equals 8 minus 8 over 2. So h equals 8 minus 4, that's 4. Now we have y prime equals cy plus k. And again, we're substituting a and a prime in red, b and b prime in blue. Negative 3 equals c times 2 plus k. And over here we have negative 6 equals c times 3 plus k. Again, there's no zeros here, so there's no advantage to using one over the other. So let's just solve for k here. We're moving this c3, we'll call it 3c instead, and move it over the other side. K equals negative 3c minus 6. I'm going to pop that down into here and substitute into this equation. So we have negative 3 equals, we'll call this 2c now, plus, and in brackets, negative 3c minus 6, and we solve. The negative 6 comes over to this side, it becomes positive, so 6 minus 3 is 3. We have 2c minus 3c, so that's minus c. So we move the negative over to the other side, and c equals negative 3. Now we substitute back this way. We take this equation and substitute the c into it. We get k equals minus 3 times negative 3 minus 6. This is 9 minus 6, so it's 3. And just a reminder, our answer is g of x equals c times f of d times x minus h in brackets plus k. Now all we have to do is substitute our values. G of x equals negative 3 times f of 2, x minus h, that's x minus 4, 2 brackets, there's 2 left brackets, so you need 2 right brackets, plus k, so that's plus 3. Okay, so the tip is use the full transform equation unless you are told only specific transforms are present. Here, we aren't told that we're using scaling or translation, so we have to assume that both exist. And for this problem, we're told only scaling and flipping, so it's only C and D. H and K are not involved. So read questions carefully and you'll be better on the tests. And that completes this lesson.